So I did the first bare metal register level code and I'm about to flash it. This is the STM32 Blue Pill and this is the connection. You will see a blinking I did previously. So that blinking that I did previously, you didn't flash yet. Let's do the flash. So we navigated to the build folder. I took some script, OpenOCD script that I can use, push the code into my Blue Pill since it is a clone chip. So I have to do it with OpenOCD because I can't do it directly from STM32 I just built the code from there. Now I'm going to push it from this. I'm going to leave the code to the video description. Let's hit enter. I'm gonna hit enter, but let's see what's going on here. So this is still blinking and I'm going to hit enter. Let's see, it is stopped because the new code has been pushed. It is clearly gone, and look at it here. The code says verify status verified, okay, resetting target, everything is being done. This I'm gonna take this off, so flashing is done. I'm gonna use this Blue Pill and this breadboard power supply. First configure the circuit, and then I will use this breadboard power supply to power the Blue Pill, and then I will connect the Blue Pill with the LED and the LED will auto blink. Guys, this is a breadboard power supply that is supplying 3.3 volt. I'm barely holding it with my one hand. The multimeter probes, one is connected with positive, the other one is connected with negative, and here it is 3.3 volts. That's exactly what we need for our 2.3 volt STM32. So I'm gonna connect this with the breadboard. I've just taken out the wires. Let me do the connection. First let me turn off the breadboard power supply, then I do the connection, then I will come back. Let me explain to you the connections first. First of all, here is the AC to DC power supply which is used. This breadboard power supply is going to supply you 5 volts and 3 volts, but I need 3 volts, 3.3 volts, so I'm going to use the 3.3 volt port. So in this circuit I have used the white wire as a positive and the orange one as a negative, or ground actually. As you can see that this positive terminal is connected with the 3.3 volt and the ground is connected with the negative terminal here. The ground, there is a common ground, and here is this positive voltage that is coming out all the way. It is to 20 ohm, and here is the LED. I don't know if you can see the legs. The longer one is connected with the resistors directly and the shorter one is connected with this orange wire. This orange wire is going all the way to the port 0. Before I go and turn on the power, let me explain to you the code. First of all, doing bare metal register level programming requires a lot of things. You will must need the reference manual here, and then I'm going to show you the other things that is necessary for you to know which pins where, and here is the code. So let me explain briefly. So here is the C code. Here is the main header. This main header is under this include folder. If I click it, then you will see that it includes the STM32 F1XX header file. This configuration you have to do that. You have to make sure the header file of that specific microcontroller that you are going to use, the header file is connected, and you have to make that sure. Otherwise that program will not know what command will do what. Your program will show error and warnings. So here is the main file. I did not use any half function. Initially I used one, but I was getting some errors, and so I avoided the all half function. I wrote only bare metal code. First of all, I want to give a huge shout out to Gemini. It helped me a lot learning this bare metal code. I learned this for about like almost 2 weeks or more because there is a drone project coming up. So for this I started learning this bare metal register level programming. So here is this delay loop, volatile. That means that the compiler is not going to ignore unsigned integer 32, saying that the parameter is going to be 32 bit. and the count is just post decrement. First of all, we are turning on the RCC, the reset and clock control advanced peripheral bus to enable a register. We are turning this third bit actually to 1, the bit 2 actually to 1 to turn on the clock. Then there is this GPIO to this CRL, the counter register low. I've already said that this is connected with the pin 0. So pin 0 is under the APB to ENR and under that peripheral bus, and also it is under the control register low. So that's why we have to use CRL, and all of these informations you are going to find in this reference manual. It is incredibly helpful. Let's come back here with the hexadecimal number 0 XF means 1111. There is this logic that I'm not going to explain now, but the first line is saying that we are going to reset the 0th position. You can use Control F, then write CRL, then you are going to get this where it will give you this. So for the pin 0, the bit 0, 1 and 2, 3 of the control register low is used for mode and configuration of the PIO pin A0. These 4 bits that are going to be configured. For that we are going to need this 0, 0 and 1, 1 output mode. We are going to need this max 50 Hz speed of the LED, so that's why we will need it. And the next code is about configuring the code. First one, 0xF is resetting, the 0x3 is the 0011 the configuration and mode. And then there is this while loop and this infinite while loop. As I said, this is an BluePillAutoBlink, so it's going to be, we're going to be using this auto infinite while loop. And this GPIO BSRR is bit set reset register, and we are turning the 0th bit as 1. You're going to know why in the reference manual. It is if you turn on the 0th position bit to 1, the LED will get the power, the output power, and there is this delay of 300k loop cycles, which I will not explain at this video because it's getting longer. There is this GPIO BSRR 16 position bit you have to turn on 1, because this is the 16th position bit. It will turn off the power or the output power. So this is how the LED is going to be blinking. So enough of explaining everything. Let's look at the circuit right here. Now let's power it on. Hopefully it works. This is my first time trying this. If the LED is broken or something, then I will need to replace it. Let's go. Bismillah. Yes! Oh my god. This is the first try. The first try, everything is going incredibly all right. I just can't believe. Now let me explain to you why this is this is the. So basically, when there is this counter going on, we are passing the 3000 loop cycles. It's going there, and the 3000 loop cycle is going to be decremented. It will start from 3300k loops cycles, and the LED will be on for that loop cycle, and then they will be turning it off, so it will be off for 3000 loop cycles. As you can see it right here, it's great. I just can't believe I did it. I want to give a huge shout out to Gemini. I learned a lot of things. I learned how to do bare metal register level programming, embedded programming. I never did it before. That's a lot of things and a lot of learnings. So thank you so much so far for watching it. I have a drone project coming up. We are going to make an autonomous drone, but I know nothing about how to make an autonomous drone. Nothing, almost not even. I mean, that's why I started learning this. That project is going to be big if I just use this AI code then I will never be able to do that. So I thought, why not just learn it? Feels like it's the best choice that I've ever done. I want to specifically work on the programming side of that drone project. So we have 6 members at this moment. Thank you. Hope all of you will be doing great. Stay productive. Bye bye. I love this.